time to use the equations. So it's actually the exact same equations that we used for our mirrors equations, which are the Lensmaker equation and the magnification equation. Now, the focal length is still lowercase f, and for lenses, it's positive if it's a convex lens, negative if it's a concave lens. The magnification still is positive if it's a virtual images, negative if it's a real image. The image distance is positive for real images and negative for virtual images, while the object distance is positive for all real objects, which are the only ones we're going to be dealing with. HI, the image height, is positive for virtual images and negative for real images. And finally, the object height will be positive because all of our objects will be real. Now, if you notice, the only difference has to do with which shape is positive and which shape is negative, because mirrors and lenses do opposite things. One way to combat that and turn this into everything agrees is to rethink this as focal length will always be positive if the device is converging and will always be negative if the device is diverging. So let's do a quick example. So our example is going to take teachers showing slides like the old school slide deck that you may have seen in previous times, and that they're positioned 15.5 centimeters from the projector lens, and the projector lens has a focal length of 15 centimeters. A, how far from the projector should the screen be placed in order to produce a clear image of the slides? And B, sketch a ray diagram to support your answer. So, what type of image is going to be produced is something we have to be thinking about in order to determine the various signs and all of that kind of stuff that we need to use. We are trying to project it onto a screen, therefore, it's a real image that we're going to produce. Another question we have to ask is, what does the fact that we're producing a real image tell us about the type of lens? Because keep in mind, even though we're told here's a focal length, we have to decide if it's a positive focal length or negative focal length based on the shape of the mirror. Or sorry, shape of the lens in this case. So, and in this, since we are producing a real image, the only type of lens capable of producing a real image is the convex lens. So we know it's convex. That tells us that the focal length has to be positive. So let's set that up. We've got positive focal length of 15 centimeters. The object, the slide, is placed 15.5 centimeters in front of the lens, and we're asked to find the image distance. We don't care about the magnification, image height, or object height. Those are things we can ignore for this entire problem. Now, we can say that 1 over the focal length is equal to 1 over di plus 1 over do. Rearranging to solve for di is equal to 1 over the focal length minus 1 over do, that quantity raised to the negative 1 power. Plugging in our values as we have them in our list to the left, and we will get that the di is 465 centimeters, and if you're wondering, that would be 4.65 meters. I know question B asks us to find the ray diagram to sketch the ray diagram for this. I'm just going to point out this is you can do that yourself, and you have the PowerPoints that you can check. This would be where the object is located in between C and F.